Okay, here we go. So, a little quick review here of stuff for our test that's going to be on Tuesday. Test Tuesday. File that one away. So, click them closed. Let's get all those, put those phones away. Don't be tempted. Put those phones completely away, everybody. No earbuds. All right, you probably can't see me up here real well. I got this camouflage mask on, but I'm up here. Just listen for my voice. What's that? Yeah, look for the reflective bald head. That'll help you out. Okay, so some stuff on piecewise functions. We'll just go through some practice problems for the test here. So what about stuff like this, where we're given a piecewise function and we're asked to evaluate the piecewise function? So how many, first of all, how many pieces are there in this piecewise function? Just show me fingers. I'm seeing 2s and 3s. Which one is it? 2. How do you know there's 2? Because there's 2 rows in the piecewise function, right? Each row constitutes a piece of the piecewise function. So if we color code these, let's make the top one, that's the red piece, bottom one's the blue piece. Okay, each one of those pieces has 2 parts. It's got the equation part that tells us what the graph would look like, and then it's got the domain part which tells us where does it live, where does it get graphed, okay? So what about, like, let's look at part A, f of -1. So what's my input value in part A? -1. That's a value of what variable? X. Okay, so which piece does that fit into then? The top one. Good. How come top one? Okay, because it's less than 0, right? -1 is less than 0, so it fits into the top one. So part A would be a red piece problem. And then I just evaluate this like I always do. I'm just going to plug -1 in for all the x's, and there's only one of them. So I get 5 times -1 plus 4. What's that simplify to? -1. There you go. So there's the answer to part A. What about part B? Does that go into red or blue? Blue. Good. It goes into blue because look at the domain of the blue. It's got an equal sign with the inequality. So any x value that's greater than or equal to 0 would go into the blue piece. Well, this is 0. So f of 0 then would just equal, I'm going to plug 0 in for x, 0 plus 5, which is obviously just 5. Okay, and we're done. No big deal. Okay, 1 to 5, how are we doing? Okay, all right. Same kind of thing. So what about part B here? H of 0. How many pieces in this piecewise function? Show me fingers. 2, good, okay. Is this going into the red piece or the blue piece for part B? H of 0. Which one? Red. Okay, what's the domain of the red one? What's that mean? Anything that's not 4. Any input number except the one, 4 is the only one we input into the bottom. Everything else goes into the top, right? So B, it's a red issue, right? So if I plug 0 in for x, I'm just going to get 0 squared minus 16 over 0 minus 4. Well, the zeros don't do anything. So I just get -16 over -4. What's that? 4. So there's the answer to part B, right? How about part C? Where's that go? Blue. Okay, because that is the value 4, so it goes in the bottom. So now every place I have an x, I'm going to plug in a 4. So what do I get? 5. There are no x's to plug in for, right? The answer is just always 5 in the bottom. There you go. Okay, give me thumbs. How we doing? Okay, so far so good. How about graphing a piecewise function? So here we've got a 2-piece piecewise function. Let's graph the top piece in red and the bottom piece in blue, how about? Okay? So the top one, we're graphing the line y equals 2x plus 5 whenever x is less than or equal to 0. Bottom one, we're graphing the line 1/5 x plus 3 whenever x is greater than 0. So first of all, what's my divider or my boundary between the two pieces? If an ant's walking on this thing, where does the ant have to jump from? Okay, 0, right? Jumps from red to blue at 0, right? So the vertical line x equals 0, which is the y-axis, would be the boundary between the two regions, right? The two pieces. So we're going to graph this one, the red one, we're going to graph to the left of 0. So that one gets graphed. We'll go up here, how about? So that one's going to get graphed over here. We've got the line y equals 2x plus 5. And over there, to the right of 0, we've got the line y equals 1/5 x plus 3. Easy enough. We just have to graph those lines in their domains. Well, this is a pretty easy line to graph. What are the two important numbers there? What do they tell us, the 2 and the 5? Slope. Okay, good. So 2 is telling us, whoops, I got snared up here. The 2 is telling us rise over run. So we should be able to build a slope triangle that goes up 2 and over 1, or up 4 and over 2, or up 6 and over 3, where the ratio is going to be 2 over 1, right? And then what's the 5 tell us? Y-intercept. Okay, so B equals 5, and that's what that is. If you notice that this is going by 2s, you got to be careful on these graphs. Sometimes they go by 2s instead of 1s. See, look, this is going, if that's 10 and there's only 5 increments, I must be increasing by 2 with every hash along the axis, right? Every notch in the graph paper is going by 2. So those seem to, well, at least the y-intercept seems to work. Let's pick a couple points and just check it out. So if I were to pick like convenient points, like how about right there and right there, what's my slope triangle going to do? If I'm going from this point up to the end point, I'm rising by how much? Okay, but remember, those are increments of 2, so I'm going up by 4, right? Everybody see that? I'm going up 1, 2, 3, 4. So I'm rising by 4, and I'm running by how much? 2. Well, that works, doesn't it? The slope, rise by 4, run by 2 equals 2, so that checks out. Okay. It's got the correct location of the endpoint. Do you see anything wrong with this one? Looks pretty darn close, if not exact, right? Is there anything you can see? Okay, what's going on? Supposed to be a closed endpoint, isn't it? Right? Because look, we've got an equal sign right there. So it's got to be a closed endpoint. So there's our one issue with this one. This is supposed to be closed. How about the other line? Let's check that one out. So we've got the line y equals 1/5 x plus 3. So what's my slope? 1/5. Okay, let's check it out, see if that works. So to go from this point, there's a convenient one right there, it looks like. I'm rising by how much? 1. And I'm running by 5. 1, 2, 3, 4, 5. Yeah, so that works. Slope checks off. How about the y-intercept? Should be 3. That checks off. It's right there. Okay, but what's wrong with this one? It needs to be open. Yeah. This needs to be, but it's not, an open endpoint. Otherwise, it looks good. Those are the only 2 mistakes, right? Okay, that was close. But no cigar. This is obviously way off, isn't it? Shapes of the lines are wrong. So that one we can get rid of. Okay, that one looks pretty good, except that bottom line's wrong. The y-intercept is wrong, right? Should be +3 and it's -3. So we're only left with one of these, and sure enough, this looks like the right one, doesn't it? It's the same shape as the first one, but this time we had the correct endpoints. We've got a closed endpoint there. And we've got an open endpoint there where it's supposed to be on the second piece, right? So that's it. There's our winner. Okay, give me 1 to 5 on that. How we doing? Good? Okay, all right. So, simple one. This is a freebie, right? This will be on the test. How easy is this? You just have to pick the correct parent graph for an absolute value function. Well, what's the shape of an absolute value function? Good, that's V, isn't it? V over 1 and up how much? 1 over 2 up. Okay, pretty boring. Which one is that? Gauge, which is the right graph then? Looks like F, doesn't it? Yeah. Okay, so there's our absolute value graph. How about that one? X squared graph. What do you think? What letter? Okay, yeah. That's a parabola, isn't it? X, the parent graph, x squared, is the U-shaped parabola over 1 and up how much? 1. Over 1 and up 1 squared, which is 1, right? Over 2 up 4, over 3 up, over 4 up 16. There we go. We got it. So there's the parent graph for x squared. All right, what about these now? So look what we're doing here. We're gonna match the descriptions in the left column, or we're gonna match the functions in the left column with the descriptions in the right column, given that we're starting off with the parent graph y equals x squared. So just a plain old parabola, vertex at the origin, right? So what is, for part A over here in the left column, which one of these options does it match up with? And just vote with your fingers. 1 is A, 2 is B, 3 is C, etc. So which one does this guy go with? Let me think. Good. Good. Okay, I'm seeing lots of 4s. That's good. So it goes there, doesn't it? And the reason it goes there is because what is that? What is that 5 there? Is it a like value of A, B, or H? What do we have here? We have one of our 3 parameters gets a value in which one? H equals positive 5. Okay. How about the next one? Where does this guy go? Down 5, I'm hearing? Okay, so it goes there. And that's because what parameter gets a value there? A, H, or K? Which one are we talking about? K equals negative 5. Okay. Okay, next one. Where's that guy? Whoops, wrong color. Where's that guy going? B, okay, because that's a value of what? A, H, or K? A. A equals 5. How about this one? Left 5. And that's because H equals negative 5. And then that leaves us 1. Part E, what's the reason there? K is 5. Good. K is positive 5, so it's going up by 5. Good. Okay, what about these? So now we want to pick the correct graph from this list of graphs for each one of these. Okay, what about this guy? So we're comparing this. What's our parent graph for all of these? X squared, right? We're comparing them to x squared. So what did we do in part A? Yeah, we're going up 3, aren't we? Because that's where k is 3, so we're going up 3. So which one of these graphs then corresponds to up 3? B does. Okay, what about the next one? Down 3. Which one's that? Yeah, it looks like A. Okay. That makes sense? Okay. Next one. Everybody agree? Left 3. Okay. And remember, we know that H is -3 there. H is the one that's always backwards. It's always going to be opposite of whatever that symbol is. So H is -3, so we're going left 3, which is, what do you think? G, I think, maybe? How about this guy? Right 3. See? How about this one? Okay, so it's stretching 3. So I'm going to go over 1 and up how much? 3. Over 1 and up 1 times 3. So that must be, what do you think? F, it looks like, is the stretched one. Okay. How about this guy? What's that one doing? -1, so over 1 and up. Ah, it's reflected. Up -1, so down 1. So which one we got? D. How about this guy? 2 things going on. Okay, yeah, so we got right 3 and up 1. Right 3, up 1. Where's that guy? H, it looks like. Right 3, up 1. Okay, next one. How about that one? Left 3, up 1. E, it looks like. How about that? And then the last one? Left 3, down 1. So I guess. Okay. How about this guy? So we got essentially, we just want to graph this thing. So what's the shape of our graph going to be? What's the basic shape? V shape, because it's absolute value. So we need to just know what are the values of A, H, and K, and that's everything we need to get our graph. So A is what? 7. Okay, so H is -3 because it's opposite of that, right? So -3, and what's K? 0. So the vertex should be at -3, 0. So can we disqualify any of those? B and D don't work, do they? Wrong vertices in B and D. So which one is it then, A or C? It's A, isn't it? Because it has to be stretched by a factor of 7. So instead of going over 1 and up 1, we're going over 1 and up 7. Okay, and there it is. Over 1, up 7, right there. So that's the winner. All right, what about this? So we've got, okay, what type of graph is this? Okay, so it's a parabola, right? It's an x squared graph. So we just need to know, again, if I know the values of A, H, and K, I should be able to graph this thing pretty easily, right? So what are they? What's the value of A? So A is -2. How about H and K? Okay, +4, +3. So what are the coordinates of the vertex? 4, 3. Okay, what about the axis of symmetry? What's the equation, Clayson, what's the equation of the axis of symmetry? It's got to be an equation because it's a line, so we need an equation. X equals 4, very good. we know that the axis of symmetry is just always x equals h, isn't it? It's the vertical line through the vertex. Okay, now what do they want us to do? They want us to graph as a solid parabola, we're going to graph the parabola using the graphing tool, which we won't do now, obviously. And then they want a dashed line for the axis of symmetry. So the vertex, we already said, is at 4, 3. So over 4, up 3. That's where I'd put, that's where I'd put that the first point that defines the parabola using that tool, right? And now I got to define a second point. A is equal to -2. So what's my roadmap to get a second point here then? Yeah, over 1 and up 1 times -2, which means down 2, right? So over 1, down 2, and that's the second point. And when you use that graphing tool, it's just going to bend the parabola for you, isn't it? What's the axis of symmetry? If I want to graph the axis of symmetry, what's that look like? Peyton. So describe the line for me. Straight up and down through 4. Okay, so it's going to be this guy. Oh, come on. There we go. Right, there's my vertical axis of symmetry. Now I know, when you're using the graphing tool, you don't even have to worry about this. It does it for you. But I know I can reflect that point over to the other side. And then there's my 3 points. And if I bend my parabola, this looks like that. Okay? Make sense? Give me 1 to 5. How we doing? Ooh, good. Man, you're going to kill this test. It's too easy. So what about this one then? Same kind of thing, only this time, only difference is they're giving it to us in standard form instead of vertex form, but that really doesn't add much difficulty, does it? We do it the same way. So what are the values of A, B, and C here in standard form? B is -4, and C is 1. Okay, so we've got to calculate H and K, don't we? All right, so let's see. Weston, what's going to be my formula for calculating H? Negative, there you go, negative B over 2A, good job. So what's negative B going to be, everybody, then? Positive 4, good. Over 2 times 1 is 2. So what's my value of H? 2. Okay, so we know H is 2. K, how do I get K? Okay, plug it into the original function. So K is going to be f of 2. And what's that give me then? K is going to equal 2 squared minus 4 times 2 plus 1. So that's 4 minus 8 is -4 plus 1. What's that? What's that? -3. Okay, so there's the vertex. We got it right. 2, -3. Question, or, yeah. No. Mm-mm. Yes. Yeah. Yeah, you're going to have to graph it on, right, graph it on here. Right. So the vertex is at over 2, down 3, right? And then what's the value of A? It's just 1. Good. So if A is 1, then it's just a regular parabola. Over 1 and up 1. That's it. Over 1 and up 1. And they want, they don't even want us to graph the axis of symmetry. So all we're doing is the parabola. We know the axis of symmetry would just go right through there, though. And so we're going to get this other point on this side, and we're just doing a regular shaped parabola. Something like that. Okay? Oops. What was it? Over 2, down 3. Oh, come on. Right there. Okay, there it is. That's what we had. Good? All right. Okay, almost there. Getting there. So, same kind of problem, little more difficult this time because a is not equal to 1, but we're just trying to do the same kind of thing. They want us to do two things. They want us to write the quadratic function in vertex form, which really all that means is I'm just trying to plug values in for a, h, and k. I just need to know what the values are. So we're starting in standard form. What are the values I'm starting with for a, b, and c? 7. B is. C is. Okay, so then what's my formula for h? Yeah, you got to know that one. Just because we use it so much, you got to know that one. So negative b over 2a, 28 over 14, 2 times 7. 2, we good? Okay, now, Brock, I will give you this though. You can use the Desmos Scientific if you want to. Yeah, you can use that, right. So then we could use, like, on this one, for example, questions on this? Question? You got it? Okay. So then we could use the Desmos Scientific like this. I could input the function, there it is, just write it in function notation as f of x, and if I want to figure out what the value of k is, well, I can just plug 2 in right there, right? And so you can do that. Yeah, you can do that. So then my answer for k, it's right here, so k is f of 2, and that's just negative 14, right? So now all I've got to do, I can write this thing in, question? Nope. Okay, so how the 14 became negative, right here, this one did. Because when we plugged 2 into the function, the output was negative 14. Really, what did we do here? We just did this. We plugged 2 in, so we ended up with 7 times negative 2 squared minus 28. Oh, actually, it's positive 2. 28 times 2 plus 14. So that's giving us 14. Actually, no, it's not. It's giving us 28 minus 56. So that's negative 28 plus 14 is negative 14. Okay, that's how we're getting that negative 14. So then what are the numbers we're plugging in? Well, we're just plugging in a was 7, h was 2, and k was, whoops, not k, k was negative 14. So if I had to write this thing out then in vertex form, doesn't it just look like this? Y equals 7 times the quantity x minus 2 squared minus 14, right? Okay, and if I want to graph it, then there's my 3 parameters. All I've got to do is graph a parabola with those parameters. So where do I locate the vertex? H and k, so 2, negative 14. So I got to go over 2 and down 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14. So clear down there. Right, there's my vertex at 2, negative 14. And A was equal to 7. So I go over 1 and up 1 times 7. So over 1 and up 7. I've got this axis of symmetry that I can reflect over, so I get another point right over there. And then I end up with, there's my parabola. Good? Okay. I think I'm going to call her quits there. I got one more example to go through tomorrow, but you got the rest of today and all day tomorrow to just work on the review assignment. Finishing up 3.4 practice 2.